Greetings, students. This video is intended to help you prepare for the Unit 3 exam. Most of you have already taken this, but if you are watching this video, it could be because you did not pass it and you're going to take advantage of the retake. So if you are watching this in that case, good for you for being proactive and responsible. If you didn't pass it, what you want to do is look at these questions, make sure that you understand the steps that I'm doing, and you want to take out your practice test, do the problems with me, and then do the ones that I don't do, and go into the answer key that I posted in this assignment and check to see if you're on the right track. You want to make sure that you're prepared for the retake so that you get a better grade. You also may be watching this video because you didn't take the test, and maybe you're just watching this so you can get prepared for the makeup. So either way, again, the steps are the same. Watch the video, do the problems with me, go back and do the ones that I'm not going to do, and use the answer key to check your work. To create a shorter video, I am not going through every question. I'm only going to go through questions from each section. So this is from the practice test that we went through in class. Hopefully you have a hard copy of that. If not, there is a PDF attached to this assignment if you want to print that out or come see me for a copy. So number one is asking us to determine the transformation that will map figure A into figure B. All that means is, how did figure A move on top of big figure B? Okay, so imagine that figure A went up and went to the left, and it's laying on top of figure B. How did that happen? So what you have to do to determine that is choose one point, only one point, and you are going to count the units, the boxes that it takes to get to where the new point is. So I'm going to start at the point at the top. So I'm going to put a little dot right there so you see where I'm starting. Don't count until you start moving. So I'm going to count 1, 2, 3. So I have to go over 3 to the left, and I have to go up 1, 2, 3, 4, 5. So hopefully you see those little dots that I'm making as I count. So I'm going over 3 and up 5. Okay? So I'm going to identify this in the blanks. I'm going to the left 3 times, and I'm going up 5 times. Okay, that's all you're doing. That is all you're doing, okay? So for the next group of questions, you are translating the figure. Instead of describing it, you're going to translate. In this case, we do need all 3 points, or however many points are in your shape. You need to use all of them and translate them. So this is asking, translate the figure 3 units left and 3 units down. It's asking us to translate. So I'm going to start with the point all the way to the left. I'm going to put a little point so you see where I'm starting at that red dot. I'm going to go over 3 units to the left. So 1, 2, 3, and I'm at 7 on the y-axis. Okay, but I've got to go down too. So don't forget to go to the left and go down. So 1, 2, 3 down. So I'm going over 3 units to the left and 3 units down. Okay, so that's where I'm going to put my first point for the shape. All right. Some students will only go over to the left and stop right there. But remember, we're translating it 3 to the left and 3 down. So we've got to do that for each point. Now I'm going to move this point here over 3, 1, 2, 3, and down 3, 1, 2, 3. Notice I'm putting my points at the intersections of lines. Okay, not inside the box or anything like that. Okay, now I'm going to do the last point, going 1, 2, 3 down, and 1, 2, 3 to the left. Okay, so this is where my third point would be. The last thing I'm going to do is just connect these dots so that I can sketch the new shape. I don't care if the lines are not perfectly straight. That doesn't matter. What matters is that you put the points in the right location. So you're going to do this for the next 4 or 5 questions. Remember, practice this and go back and check your answers. Okay, starting at 11 or so, you are going to plot the new shape by understanding how the points change when a shape has been rotated. So we're not doing translations anymore where we're just moving up, down, left, or right. Now we are rotating the shape. Rotating, the easiest way to approach these rotation problems is to understand how the points change. I gave you a chart. Hopefully you have that with you to understand how they change. If you don't, you need to get that from me because you need to refer to that chart to do these questions. So in this question, it is asking us to rotate the figure below 180 degrees counterclockwise. That is all the information you need. You really could just ignore all of this information here because you don't need any of that. You only need to know the degree, which is 180 degrees, and the direction, counterclockwise. Okay? Now, some students are asking me, well, which way is counterclockwise? Is that like moving to the right or moving to the left? Don't worry about all that. You could be overthinking it. Just use the chart to understand how the points change. Okay? So we've got this quadrilateral here that we're going to rotate 180 degrees. Remember that a quadrant is 90 degrees. Every quadrant. So from this line to this line, that's 90 degrees. From this line to this line, that's another 90. This is another 90, and this is another 90. A full circle is 360 degrees. If you divide that up into 4 quadrants, each quadrant is 90 degrees. So how can you determine where this shape will land? Well, if it's traveling 180 degrees, we know that it's going to go through 2 quadrants. And this is counterclockwise, which is in this direction. We're going 1, 2. So we know it will end up over in this quadrant right here that I just circled. Okay. Now, when we move over to that quadrant, all the points in that quadrant that we're going to land in are negative, negative, positive. Your x values will be negative and your y values will be positive. Remember how the coordinate plane works. Okay, so if we look at the shape where it is, all the x's are positive and the y's are negative. So think about how these points are going to be changing if they end up in this quadrant. Now your x's are negative and your y's are positive. Okay, so what happens is when we have a 180 degree turn counterclockwise, the points stay the same, but the signs change. So 3, negative 5 becomes negative 3, positive 5. So the numbers don't flip. 3 still stays in its place, but the sign changes. Instead of positive 3, we've got negative 3. Instead of negative 5, we have positive 5. And you can use that same format for the rest of the points. So instead of 7, negative 6, we get negative 7, positive 6. All of our x's are negative, all of our y's are positive. For 7, negative 3, we get negative 7, positive 3. And then for 5, negative 1, we get negative 5, positive 1. Okay? So once you change the signs of your points, then you are going to plot the shape. You're going to plot the shape. This is really small on my screen, but I'm going to do my best. Hopefully you understand what is happening. So now that I've plotted these shapes, or now that I know what the points are, I'm going to go over to that quadrant and I'm going to plot the points. So I'm going to start at negative 3, 5, which is here. Okay, and then I'm going to go to 5, negative 7. I'm sorry, negative 7, 6. That's the next point. So negative 7, I'm going to go up 6. Okay, so we're right here. And then I'm going to go negative 7, 3. So I'm going to go negative 7, 1, 2, 3. And then I'm going to do negative 5, positive 1. So negative 5, positive 1. Then I'm just going to draw my lines to the points, and I'll have my new rotated shape. Okay, so let's just recap the steps here. First, read the degree and the direction. then find it on the chart. The chart will tell you how the points change. Change all of the points and then plot the points on the graph. Connect the points and you will have your new translated shape. Okay, I'm going to do one more because I know these are a little bit tricky, so watch me walk through one more. If I were you, I would just pause this, maybe do it on your own, and then play the video again, make sure that you did this correctly. So now we're traveling 90 degrees clockwise, 90 degrees clockwise. So we're going in this direction, but we're only going 90 degrees, okay? So that means that the shape will end up in this quadrant right here, where all of the x points are negative, positive. Your x's are negative, your y's are positive. Okay, so when we have a 90-degree rotation, the points are the values that make up the coordinate points switch places. So here is the rule, and hopefully you have that cheat sheet that I created in front of you. It would be wise to have that while you're doing this. So what happens is, instead of you having x, y, what's going to happen is x, y turns into y, x. You just switch places. Okay, now one other thing happens. Notice if you move to a different quadrant, one of the values is going to change. One of the values is going to go from either negative to positive or positive to negative. So in this quadrant that we're moving to, we're going from negative to negative positive. So it is your y value that's changing here. When you're moving clockwise like this, your y value, or the value that's on the end, is going to change. Our y value is not going to be negative anymore. It's going to be positive. So this is what happens. XY turns into y negative x. What used to be your x becomes your y, and the value changes. So for example, -6, -7 here, so we're going to switch places, and then we're going to change the value of -6 to +6. So your x now is -7, and your y now is +6. Notice we did not change the sign of -7. That stays -7. We're only changing one sign, and that was -6. We're changing that to +6. So we're going to do the same thing. All of our points should be negative, positive. All right, so we've got -3, +4. Changing the sign doesn't mean you end up with a negative. Changing the signs means that you just change the sign. So if you have a negative, it turns into a positive. If you have a positive, it turns into a negative. Okay, so we've got -1, +6. And we've got -3, +7. All right, I'm going to plot these points so you see where the new shape is. So -7, +6. I'm going to go over here, -7. We're going to go up to +6 right here. Okay, and then we are going to plot -3, +4. So we have -3, 1, 2, 3, 4. I'm going to plot that at -3, +4. -1, 6. So go over -1. We're going to go 1, 2, 3, 4, 5, 6. Okay, and then our last point is -3, 7. So we go over -3, and we're going to go up this time to 7. And then we're going to draw the shape. Now, if you're thinking like, oh, that shape looks weird, it doesn't look like the shape that I had below, it shouldn't look exactly like that because the orientation changes. Remember, when you're rotating something, what the top is moving, okay, so it's just pointing in a different direction, that's all. And that's what happens when you rotate things. So don't worry if it looks strange. It shouldn't look like this anymore. Okay, it shouldn't look like that. Okay, that's why I'm drawing a big X over that, because it should be rotated. Okay, next question. Reflect the figure over the line x equals 1. Reflect the figure over x equals 1. All that means is you're going to draw that shape, and you're going to make sure the points are the same distance away from the line of reflection, the same distance away from the line of reflection. So where is our line of reflection? It's at x equals 1. That means this vertical line that's going through positive 1 on the x-axis, this vertical line. So we want to make sure we draw a shape to the left of that line. So imagine this shape flipping over to this side, just flipping, okay? So we've got to count the distance between the line and the points. So I'm going to start at 1 point, and I'm going to count 1, 2, 3. So it takes me 3 units to get to that line. So I'm going to count to the left 3 times. 1, 2, 3. So this is where that point moves to. Okay, the other point down here is also 3 away from that line. So I'm going to go start at the line and count 1, 2, 3. So I have a second point. Now I'm going to do this point all the way at the top. 1, 2, 3, 4, 5, 6, 7. Takes me 7 units to get to that line, so I got to go 7 over to the left. Let me erase this arrow up here. Okay, so I'm moving 7 over to the left. 1, 2, 3, 4, 5, 6, 7. So that's where that point is going to reflect to. And then I'm going to do the last 2 points here. Okay, so this point is 1, 2, 3, 4. So I'm going to go over to the left side. 1, 2, 3, 4. And then I'm going to do this last point here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay? And then I'm just going to connect the dots. And again, it doesn't have to be perfect, but it's the points that need to be reflected over that line. Okay? So in this next image, we are reflecting the shape below. I wanted to do another one of these because will be a vertical reflection, where the other one was horizontal because it was flipping over and x equals 1, I believe. But in this case, this is y equals -1. So this will be a vertical flip. Okay, so we're going to do the same thing though. We're going to count the points, see how many units the point is away from the line. So if you start at this first point, I'm going to just go up 1. Okay. All right, and so I'm going to start at the point and just go up 1 and put my first point. That's where my first point will be. Then I'm going to go to a second point here. It's 1, 2 away from the line. So I'm going to go 1, 2 above the line. Okay, and don't confuse the line of symmetry right here. The line of symmetry, or we could say LOS, don't confuse that with the x-axis. Okay, I think some people did that. So that's LOS, line of symmetry. All right, I'm going to go to the point down here. 1, 2, 3, 4, 5. That's 5 away from the line. Then 1, 2, 3, 4, 5. So we got 5 here. This is where the other point. And then this last point all the way down here at the bottom. Okay, that is 1, 2, 3, 4, 5, 6, 7, 8 away from the line. So I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So here's a new point all the way up there. Then I'm just going to connect the dots. And then this is where I don't care. Again, it's lines are straight. It's kind of hard to do straight lines without a ruler. Okay, so there we go. The shape is reflected. I'm more concerned with where the points are. All right, so for the next, the last set of questions are related to triangle congruence. And what you're doing is you're looking at the shape And you're trying to figure out if you can prove that the triangles are congruent based on the shortcuts that we learned. If the shortcuts don't work, you cannot prove that it's congruent. So if we look at these shapes, let's look at 21. Determine the relationship. What's the relationship between these two angles? Well, we know that these two sides are the same. We know that these two sides are the same. And we know that they are both, looks like they're both right angles if I'm looking at that. So they're both right angles. Remember, when we have right angles, we want to see if we have hypotenuse leg. So we do. We've got a hypotenuse. Get rid of that. We've got the hypotenuse, which is right across from the right angle. And we know that one of the legs are the same. So we can say they're related by HL, and you don't have to spell it out. Okay, and how do we know that? Because the hypotenuse is marked here and here. Remember, that's directly across. Now, some of you on the test wrote hypotenuse leg because it was a right triangle, but the hypotenuse was not marked. We didn't know anything about the hypotenuse. If you don't know if the hypotenuse of both triangles are equal, you cannot choose that shortcut. So we can say that it can be proven. Now, you could just put the letter, I think it's A. So you can just put A. You don't have to write out can be proven. All right, I'll do one more of these. Let's look at 21. We've got a angle that's the same, and we've got two sides. So that's side, angle, side. Side, angle, side. I'm going to do this a little bit better. I'm going to circle what is congruent. So we've got a side, an angle, and a side. So that is side, angle, side. Okay, and then we can put B instead of, you don't have to write out, they cannot be, well, they can be proven. You don't have to, and that shouldn't be B. I'm sorry, I don't know why I selected B, because that's not true. It can be proven, so it should be A. Okay, it should be A. It can be proven through side, angle, side. Now, if we look down here, we've got angle, side, side, and this is the one that doesn't work. Remember, that's the bad word, ASS. So you can write that. It's okay. And it does not work. Okay, just because you write it don't mean you have to say it now. But we're going to put B here because this cannot be proven congruent. Okay, here, these are the proofs. And the proofs, you're basically just creating congruent statements. But you need to make sure that you write them using notation. So, for example, I know that this is a right angle, okay, because it is identified, and you don't have to write that out. But because it's a right angle, I want to check for the hypotenuse, and I can see that it is the same, okay? So, I think that is an R. Okay, I think that's an RP. All right, so the congruent statement will be segment RP is congruent with segment DC, or CD rather. CD. Okay? Now that is given because it's marked. If something is marked, that means that the problem is giving that to you. Those two markings mean that RP and CD are the same, are congruent. We can also say that about OP. So we can say that OP is congruent to, let's see what letter this is. E, okay, to ED. Okay, OP, segment OP is congruent with ED. And I'm sorry I can't fit this into these little boxes. It's easier to write it on paper than to do it on screen. So now that I know these two sides, one is the hypotenuse, and one is a leg. So the reason that they are congruent is through HL. Remember, that only applies to right angles. But we've got the hypotenuse is the same, and one of the legs is also the same. So we know that they can be proven congruent. Okay. Now, I only need those two things to prove that the two right triangles are congruent. In this next one, we've got an angle, and a side. We already know right there that works because that's one of the 5 shortcuts. Angle, side. So the only thing left is to write the congruent statement. So in this case, angle notation will be angle K is congruent to angle A. And you're going to do the same thing for angle M and angle Y. So angle M is congruent with angle Y. Okay. And then the last thing you want to do is identify this side right here. It's KL. Okay, so KL and looks like AZ. I hope that's an A. Guys, these letters are so hard to see. Okay, so you want to say that side KL is congruent to side AZ. And don't forget to put the little line of the letters. So we've got an angle, and a side, and that can be proven congruent, okay? So that's what you're just doing. You're writing the congruent statement. Most of the time, it's already given to you. All right, and then when it's not given, or when you don't know what the reason is, then you're going to have to put that. If it's given, you're going to write given. So for 27, it's a little different. They're giving you the congruent statements. Angle ADB is congruent to CDB. Angle A is congruent to angle C. And segment BD is congruent with BD. So all we're going to do is write what's given. So we know that ADB, here's ADB, and here's CDB. Well, we know they're congruent because they're marked. So that is given. When the marking is there, that means the problem is telling you that they are. And angle A and C are also given. So you're going to write given there. Segment BD is equal to congruent to BD. It's the reflexive property. I'm not going to write that in though. But reflexive property, remember, reflexive property means that something is equal to itself. So we have angle, side. That is angle, side. Okay? All right, so the last couple problems are just like that. I'm going to stop right here. Hopefully this makes sense. Oh, I will just point out that 28, you have to remember that when you're given anything about parallel lines, think about transversals. If these are parallel lines, if you got a transversal that cuts through, you end up with alternate interior angles. So they tell you BAC is congruent to DCA. You can just abbreviate that, alternate interior angle. So that is a clue. Anytime you're dealing with parallel lines, you're going to have alternate interior angles there. That's one of the reasons that you can say those two angles are equal. All right, so I'm going to wrap up here. Remember that after you watch this and you do the practice questions, you feel ready to take the test, you need to come let me know when you're going to do it. It needs to be after school, Monday through Friday of next week, before the break.